we'll do one more for today. So this is example 14.3 on page 469. So the chemist runs this experiment. 2NO plus Cl2 gas turns into 2NoCl. These are the different trials. Hopefully I did them correctly. Trial 1, trial 2, and trial 3. So again, when we're picking our trials, we need to make sure that only one thing is changing. So when I'm writing my rate equation, rate equals our rate constant times the concentration of the two reactants, NO to some exponent, Cl to some exponent, and we're figuring out our exponents first. So I want to look where this doubles, but this does not change. So where this doubles and this doesn't change, it's going to be the concentration of NO. So when this doubles, this doesn't change. What happens here? If I can't see that one, I might have to get my calculator and do 0.19 times 2, 0.19 times 4. Oh look, this goes up 4 times. So where this doubles and this goes up 4 times, my exponent is going to be 2. So that means that's going to be a 2. So when my concentration doubles and my rate goes up 4 times, I'm going to have an exponent of 2. So now I'm going to have to figure out the exponent of this. So I want to know chlorine, where chlorine changes. Oh look, it changes, doubles here, and here this doesn't change. So where this doubles, this doesn't change. I'm going to look at this rate. So 0.076 to 0.152, that only goes up 2 times. So when my concentration doubles and my rate also doubles, I'm going to have an exponent of 1. That means the concentration of NO is going to be a lot more telling on our rate than the concentration of the chlorine gas. So now I have that. I now want to figure out what my rate constant is. So to do that, I pick one of my trials, doesn't matter which one it is. I'm going to do the same one that they do in the book just so that my numbers match. So they did the first trial. You can pick any one you want. Your numbers are going to come out the same. So you put in the concentration of NO, 0.50, and again it's molar. Concentration of Cl, which is 0.50, again it's molar. Again, your units are going to all be different no matter what, because now this is going to be m squared times m. And my rate is going to be 0.019 m over s. So I would have to square this times this, so really 0.5 cubed. So I'm going to go over 0.5 squared times 0.50 m. So this is going to take care of one of these m's, and my unit is going to be 1 over, I still have m squared times s now, equals my k. So take your calculator, 0.019 divided by, use your parentheses, 0.50 squared times 0.50 or 0.50 cubed, and you'll get 0.151 over, your units are m squared times s. So then I need to rewrite my equation. You will rewrite it, don't erase yours. So my rate is going to be 0.151 over m squared s times, or actually you could just use these brackets, times the concentration of NO squared times the concentration of Cl to the 1. If you don't write the 1, it's not a big deal, but I like to show it because I figured it out. Okay, so then any other trial that you run, you could just put your concentrations in and you'll get how fast your rate will go. All right, so again, the kicker is figuring out what trials you're going to use to get your exponents. You always pick the one where one thing changes and the other thing does not change. So this one changes, this one does not change. So, and on your test, they're all going to be different. So just look carefully at your charts. Good luck.